Okay, here we have the resonator, and what we're trying to do is to make resonant frequencies which actually cause the rings to move. So this is a very low frequency. It's probably around about what I'd say 3 hertz, and you can see that the rings, the larger rings, are actually responding quite clearly to this. This would probably be a little bit like an earthquake. Okay, you can see the larger rings are moving backwards and forwards. Okay, so let's just see what happens at a higher frequency. So this would be about 5 or 6 hertz, and you can see the rings in the middle are actually moving quite rapidly, and I'm also getting some response in these rings down here. And then we really try to wing it up, and you can see probably at about 10 hertz, I'd say, maybe not that much. You can see the rings at the far end, and some of the resonance actually goes into the larger rings, but you can see the rings at the far end. And if I really do it quickly, I have to pick it up to do it, but as you can see, if I can shake it hard enough, you can see that by shaking it there, the rest of the rings stay relatively still, and yet the ones at the end. And the other way we can do this as well, which is quite interesting, is to also look at how, by shaking it backwards and forwards like this, you can see I introduce resonant frequencies in the ring, even in a lateral component. If I do it very slowly, you see the larger rings are actually moving backwards and forwards. But if I do it very fast, and the faster I do it, the more it travels towards the smaller rings. But you can see the main resonant frequency comes in those sort of medium-sized rings. But certainly you can see from very slow, sort of 2 hertz up to faster frequencies, you can see the resonance actually travels up to the smaller ring. And this is mainly a problem with engineering, but also with the building construction in earthquake zones. This is the amazing resonant rings, and I'm looking for ways to actually perfect this experiment.